Okay, welcome America, welcome Taylor Swift to today's recording in Studio 212 for pre-calculus. Today we are going to go over how to find the domain of a composite function. And I'll hopefully be attaching this worksheet. So we have, these problems are tough. They're tough every year. I'm gonna try to get through two, I may only get through one. We'll see what happens. Suppose that f of x equals 1 over x plus 2 and g of x equals 4 over x minus 1. In problem 11, we actually don't even need g of x because we are trying to find f of x and then state the domain of the composite function. So we went through problems just like this, very similar, where we found f of x just a minute ago. And then stating the domain is the tricky part. But let's go ahead and find f of x first, and then we'll worry about the domain. So I'm going to rewrite this. I'll rewrite this as f of x. So we can see that f of x is our input. And we're going to start with the inside, right? So we're going to go ahead and plug in f of x, 1 over x plus 2 for our x. So if I rewrite this, this is going to be f of 1 over x plus 2. That's our input. So let's do it. Our equation for f of x is 1 over x plus 2. But our new x is now 1 over x plus 2. So 1 over, am I recording? Yes. 1 over x plus 2. That's our new x plus 2. Now, tricky part. Algebra. Yay! Who loves fractions? Woo. America, nobody raised their hand. Not one person. Did you raise your hand, Andrew?
No.
You didn't. No.
I hate fractions.
Okay. So let's see if we can't. I've got two terms in the denominator, and I need to add them together. Right now they have different denominators. Can't add fractions unless the denominators are the same. So I need to make the denominator of the 2. Currently it's now 1, right? This is an over 1. I need to make that an x plus 2. So in a different color, I'm going to multiply this 2 by my special one, which is going to be x plus 2 over x plus 2. And you know, there are different ways of doing this, but I'm just going to go ahead and do this. So this is 1 over. Now these are in parentheses. They never put parentheses around the numerator and the denominator of fractions, but you need to get used to them being there. It's a huge, especially for calculus next year. Here, teachers complain about that all the time. You've got to know that there is a parentheses around the numerator and a parentheses around the denominator of every fraction. So this is 2 times the quantity x plus 2, which is going to be 2x plus 4. And the denominator is x plus 2. So in our denominator, I have 2x plus, in the numerator of the denominator, I have 2x plus 4 plus 1. Are you with me? 2x plus 4 and then plus that 1 there. That's the numerator. So that's 2x plus 5. The denominator, we can now add these two fractions together because the denominators are the same. We never add the denominators, right? If we have 1/2 plus 3/2, that's a total of 4/2, right? We don't add the 2 and the 2 and say that's a 4 in the denominator. So the denominator is still x plus 2. Now, do you guys remember keep, change, flip? Keep, change, flip. In our denominator, we've got a fraction. And we are dividing. 1 divided by this number. We don't divide by fractions, we multiply by the reciprocal. So this actually becomes x plus 2 over 2x plus 5. Keep, change division to multiplication, and flip. Should I write that out?
Yeah.
Okay, so I'll write it out and then I'll erase it. Keep the 1, change the division to multiplication, and I'll put this as a 1 over 1. Flip that. X plus 2 over 2x plus 5. So I just did this all in my head. So this numerator becomes x plus 2, denominator becomes 2x plus 5. So I just wrote it there. And you'll just start writing this. You don't need to go through this every time, but this is why it's this. How's that? Okay? All right, I'm definitely gonna run out of room for this problem. It's fine. It's fine. It's all good. It's almost Friday. Are you guys going to the game tomorrow night? We need everybody to go to this game tomorrow night, y'all. I'm serious. How are we gonna do this?
We're gonna win.
We are gonna. If we, do you guys know how excited I will be if we win that game?
Bryce Duke can't carry them this year.
Hey, that was my idea.
I know.
It's
It's
true.
a great
It's
idea.
true. Okay. So, all right. So now, and I think everyone's playing. I think everyone's
Yeah.
better now, right?
Becky playing, Peyton's playing, who else is playing?
Sean's playing.
Sean's playing.
Everyone's well.
They started.
Okay, so now let's talk about the domain of this composite function first. Okay, domain are all the possible x values of this new function. We have to look originally at what did we input? We inputted this 1 over x plus 2. Okay, we cannot input an undefined number. So I know before I start that we can't have this be undefined. What value makes 1 over x plus 2 undefined? Mm-hmm. Why is that? Oh, it's on the eraser. Okay. Just looking at the input here, just looking at f of x, if this x value is -2, I have inputted an undefined. I put in a 1 over 0. I can't input 1 over 0. So I have to pull out of my domain that starts as all real numbers, I have to pull out a -2 because -2 isn't going to work. Okay, so I know that right away, even before I start. Now I also have to look at the composite function and make sure there are no values that make this denominator 0. Are there any values that make this denominator 0? I mean, how would I find that out? I would set 2x plus 5. Do I want to set that not equal? I'll just write not equal. It can't be 0. So what is that? You can probably do that in your head, but that's going to be 2x. And then you divide by 2. So x can't be -5/2. So x can't be -5/2, and x can also be -2. So those are the two values we're going to take out. So for the domain, I'm just going to write the domain and colon. We're going to write x. You can just write x cannot be, bless you, -2, and x cannot be -5/2. If we were writing that in interval notation, we would say, let's not do that right yet. I want to make sure I have enough time. We're already at 8 minutes. I may have to stop, but we'll see. But can we go, does anyone have any questions about this so far? The most confusing thing I think, and I've noticed over the years about the domain of a composite function is you are checking the input and you are checking the composite function. You do not need the function that you're inputting into. So in this case, it's kind of confusing because the function, it's f of x. Do I have another problem? Where's the next one I was going to do? Let's go to 16. Can I erase this? Okay. I think 16 is a little better example for what I'm about to say. Finding the domain of f of g. So now we've got two different functions here. So f of g of x. This is what we're looking for, the domain of f of g of x. Okay, so our input is our g of x. So right away, what do we know x can't be?
1.
What makes our input
0.
undefined? X cannot be 0. Okay? Now, we're also going to look at the composite function. So let's go ahead and do that. So let's plug in g of x into f of x, 3 over. Now our new x is our input, which is g of x. There's our new x, minus 1. So this is g of x, or sorry, this is f of x, and we're inputting g of x for x. We've already identified that we cannot have x equaling 0. But now let's look at the composite function and see what else can be equal to. Another way to do this, rather than going through all this work, is to look at the composite function now and say, well, I know that 2 over x cannot be equal to 1. I already know it, because if that was equal to 1, then the denominator would be 0. So how do you do this? And you probably don't remember how to do this, it's fine. Let's say you have 2 over x equals 1. Do you guys remember that you can switch these numbers? So x can't be 2. Do you remember that? It's back from geometry when we were solving for, I'll do that in a different video. Another way you can think about this algebraically, if that's confusing, is to multiply both sides by x, and then you get x can't be 2. So go ahead and put x can't be 2. So I already know x can't be 0 and x cannot be 2. But let's go ahead and finish our composite function and look at the composite function and just verify that that's right. Okay, but you don't have to go through all this if you want to do it that way. So I'm going to have to multiply by x over x. So this is 3 over, and this is 2 in the numerator of the denominator, 2 minus x. 2 minus x over x. Keep change flip, and this ends up being 3 over 1 times x over 2 minus x. And that ends up being, because that's a 3 over 1, 3x over 2 minus x. Now, take a look at this composite function. We went through all this work, and now we can tell x can't be 2. We knew that before we started. But this is another way you can do it. You can go through and find the composite function and look at that. So in summary, you have to look at the domain of the input function and make sure that you're not inputting an undefined value. And you have to look at the domain of the composite function and make sure this is not undefined. Notice we did not look at f of x. We did not take out a 1, because a lot of people look at this and say, oh, x can't be 1. X can be 1. Because all we're doing is looking at the domain of what we're inputting and the domain of the composite, not f of x. Are we good? All right, this video is long enough. There's no questions? All right, I'm gonna let you guys process this and then we'll see what happens.